So we've been working on sequences a lot, and we've had some situations where you're given a couple terms in a sequence. Let's say they go 12 and then 6. And it asks you to kind of think about the pattern, maybe extend the pattern, maybe jump ahead quite a bit. So if I want to think about those two terms on this sequence here, I can graph those by putting a dot. Let me make this prettier. Let's go. Okay, putting a dot right here at 1, 12. What I'm saying is the first term is 12, and then putting another dot right here at 2, 6. The second term is 6. And now if I asked you what comes next, you should say, I don't know, because I don't know what kind of pattern it is. It could be a geometric pattern, it could be an arithmetic pattern, it could be some other type of pattern. So there's no way to know given just the first two terms. The two main types that we've been studying are geometric and arithmetic. So let's think about if it's geometric, what does that word tell you? That means that we're going to multiply or divide. So I know that my common ratio is whatever 6 divided by 12 is, that's a half. Some of you guys might like it more as 0.5. Some of you probably just looked at it and said, oh, that's a dividing by 2 pattern. So if it's geometric, then my third term would be right down here, because 3 is half of 6. My fourth term would be right here, because 1.5 is half of 3. My fifth term would be right about here, because 0.75 is half of 1.5. So each time I go to the right for a geometric pattern, I am multiplying by 0.5, aka I'm dividing by 2. Now let's switch colors. If it was arithmetic, then my common difference, how much it changes by, is 6 minus 12. That's negative 6. A lot of you would say, oh, it's just going down by 6. So my first term is still 112. My second term is still 2, 6. Then I go down 6 more, so my third term would actually be at 3, 0. And my fourth term would be down there at 4, negative 6, because I'm just subtracting 6 each time, over and over and over again. So for my geometric pattern, the way I get the next term is I take the previous term and I multiply it by a half. Or I could say I divide it by 2. For my arithmetic pattern, the way I get my next term is I take my previous term and I minus 6. Or you could say you add negative 6. Okay? Where we're going to go towards is taking those and then writing an equation for them. I'll show you just how those, writing a explicit equation for them. We've already done recursive equations. I'll show you kind of just how it looks. Here's one equation for g of n. It's going to be 12 times 1/2 raised to the n minus 1. Oops. And you can see that red curve goes through those dots right there. If I was being really picky, I should make it not go on the in-between and just go skipping from dot to dot, because our sequence only goes from 1 to 2 to 3. It doesn't go in between. But I'm not going to be super picky. And our arithmetic one, it also starts at 12, but instead of multiplying by a half, it adds negative 6, it subtracts 6, and instead of just subtracting 6 once, it subtracts 6 and minus 1 times. And again, you can see that goes through those dots right there. Okay, so in another video, I'll focus more on just like how did we get these explicit equations right here. I just wanted to review here the two different types of patterns that we spent a lot of time studying, how you can write the two different recursive equations, how you can see that as a graph, and then just foreshadow that soon we're going to be doing those explicit ones.